Hello friends, so today in this video I will be explaining you all about how the development of the monocot embryo takes place. So you have already must have gone through my first video which explains the development of the Dicot embryo. So similarly in the same diagrammatically I will be explaining you all how the zygote undergoes various several divisions and then how the final development of the embryo takes place. So before we begin, just let's differentiate between the monocot and dicot embryo. So as the name suggests, monocot is it consists of a single cotyledon in its embryo, while dicotyledon it has two cotyledons. So if we see the position of the cotyledon, so in monocot it is terminal, while in dicot it is lateral. And there's another major difference in the monocot. So that is the coleoptile, which is the covering sheet of the plumule, while the coleorhiza, that is the covering sheet of the radicle. So these both are absent in dicot embryo, while it's only present in the monocot embryo. And again, there is scutellum. Scutellum is only present in monocot embryo, while it's absent in the dicot embryo. So when I will explain you all, so you all will get to know what exactly I mean, what is coleoptile, what is coleorhiza, what is scutellum. So these all things will be cleared when I will explain you all step by step. So let's proceed with the explanation. So let's begin with the development of monocot embryo. At first, as we know, the zygote, it undergoes mitotic division under the favorable condition, and it forms two cells. So the two cells are apical cell and the basal cell. So apical cell is present towards the chalazal end, while the basal cell is present towards the micropylar end. So here the embryo is a two-celled stage. Later what happens is, so here I think you must have seen in my earlier video, that is development of dicot embryo. So zygote, it divides first initially into two cells similar to the monocot, but now there is a slight change. So the change is like the basal cell, it remains as it is. There is no division in the basal cell, but what happens in the apical cell is apical cell further divides into two, and it forms a terminal and a middle cell. Therefore, here we will observe a three-cell stage embryo. Okay, so as we know, basal cell does not divide, it remains same, while the apical cell, it divides into the middle cell and the terminal cell. So terminal cell leads in the formation of the cotyledon, and as we know, we are talking about the monocot embryo, that means it will have only one cotyledon. Okay, and when we are talking about middle cell, so middle cell plays a major role in the embryo development, because the embryonal axis is formed, which gives rise to the plumule, then the epicotyle, then radicle, and the hypocotyle. So plays a major role in the embryo formation. So here the embryo is called as a three-cell stage embryo. Okay, now further what happens is, as I earlier told you all, basal cell remains the same, there is no change, but in what happens is the division takes place in the middle cell as well as the terminal cell. So when there is a lot of division here, so during that time the embryonal axis takes place in the middle cell, and again beside this cell, in the middle cell, you can see there is a slight 7 to 8 division takes place here. So this further it gives rise to the suspensor. Fine. So now what happens is the terminal cell. So here the terminal cell divides more towards the left hand side. So the division is more towards the left side. While so as the division is more towards the left hand side, so then what happens, there is a pressure exerted on the middle cell. So the middle cell, it moves more towards the right hand side. Okay, terminal cell moves towards more towards the left hand side, and as the pressure is exerted, the middle cell, it divides more towards the right hand side. So what kind of embryo will be formed? So I'll show it here. So you can get a clear picture here in this diagram. So what I was saying is, as I have marked this into the red color, so this is the terminal cell. Okay, so as I said, terminal cell moves more towards the left hand side, and as the terminal cell divides more towards the left, what happens, it exerts pressure on the middle cell. So now here what I have done is middle cell is marked into the as the blue color. Okay, so then it's easy for you all to understand, so I have used these colors. So red, this is the terminal cell, while this portion is the middle cell. So this has moved most towards the right hand side. So now this has slowly, it has started forming a embryonal axis. Okay, and here the division which was there beside the middle cell, so here this is the suspensor cell, while this is the basal cell. Okay, so this formation takes place. So now further what happens is, further this suspensor and the basal cell, they later disintegrate, they dissolve. Okay, so then these both they dissolve, and further what takes place is a proper embryonal axis, it divides it into the two. Okay, so here the lower portion is the hypocotyle, while the upper portion, this is the epicotyle. So the similar hypocotyle, epicotyle, these both are observed in the Dicot embryo, you all know it. So I've already explained this in my earlier video, so you all can go and check it on the Dicot embryo, the explanation of Dicot embryo. But here you will observe that the hypocotyle is divided into a radicle, and the radicle is covered with a root cap. Fine. While the epicotyle, it has a plumule. The plumule is present inside the epicotyle region, while the radicle is present in the hypocotyle region. Now there is another interesting factor which I have told you. So the sheet which we see covering the radicle, the sheet covering the radicle is called as coleorhiza. Okay, while it has another sheet that is covering the epicotyle, that is covering the plumule region, so that is called as the coleoptile. Okay, so coleoptile and coleorhiza, these are the new terms which are not seen in the Dicot embryo. Now here this you can observe, now this has formed a thin papery sheet. So this looks like a thin papery sheet, and it is called as the scutellum. So this is the scutellum. Further, what happens here, it forms into a complete monocot embryo. So now there is a proper scutellum. So this scutellum, it forms, it covers the cotyledon with a papery sheet. So here you can observe there is one single cotyledon present, and the function and the point where the cotyledon and the hypocotyle join, so this portion is called as the cotyledonary node. So again here you will be able to see the coleorhiza and the coleoptile. So now there's another interesting factor here, so that is the epiblast. So what is epiblast? Epiblast is a rudiment of cotyledon. So what do you mean by this? There was earlier it was already there as a rudiment. So from this itself, so it's always said that dicots are formed, monocots are formed from the dicots. So from in this manner we understand how the zygote, it undergoes several divisions, and then how it forms the 3-cell stage, and then how further it forms the embryonal axis, and then how the cotyledon, a single cotyledon is formed, and finally we have seen the development of the monocot embryo. So I hope you all like this video, and please do subscribe my channel, and please kindly share. So thank you for watching.